The organization I represent, Reasons to Believe, really focuses on new reasons. You can see that by going to our reasons.org website. Every day we post a new scientific discovery that gives additional evidence for our biblical creation model. And one of the things I try to do as the president of Reasons to Believe is to put myself on the non-theistic organization's mailing lists, just to see what they're having to say about creation and the biblical creation in particular. And what I've observed is that they have numerous repeated complaints that they make about the intelligent design movement in general. Do I need to use this microphone? Okay. And this next point, these are the 5 things I see repeatedly in their literature as they complain about intelligent design and the intelligent design movement. They say there's no testable model, that intelligent design is not repeatable or observable, there are no predictions flowing out of intelligent design research, there's no refinement of the models, and that intelligent design tolerates provably failed creation models. And we heard these complaints last night. And so I'd like to try to address these complaints. I think they must be addressed if we as intelligent design theorists are to have any credibility. And what I've been proposing at Reasons to Believe, along with my colleague Fuzz Rana and the rest of our scholars, is that we heard last night that we have this big tent strategy in intelligent design, and several of the speakers talked about we can make the tent work better by making it bigger. And this is exactly what we're proposing, that we develop a better, bigger tent. In other words, we insist that within the intelligent design tent, everyone must have a model, a fully developed model that is testable, falsifiable, and predictive. But we need to be aggressive in developing many more models than we have so far, and to set up a free market system where they aggressively compete with one another in terms of their testability, falsifiability, and their capacity to predict future scientific and theological discoveries. And then we need to be ruthless in rejecting the failed models, refine those models that are successful, see what we can do to make them better and increase their explanatory power, and then to challenge non-intelligent design models with short-range predictions. And what I mean by short range are scientific discoveries that are likely to be forthcoming, say within the next 6 to 24 months, so that within a period of a year or two, people can tell which model is proving more successful than the other models. Now, to make this work, it is critical that the different participants within the intelligent design camp begin to identify the designer. Now, the designer I choose for our creation model is that Jesus Christ, the creator God of the Bible, is the designer. Now, I'm willing to admit right off the bat, we cannot prove that in an absolute sense. Science can't do that. Science, for that matter, cannot prove in an absolute way that I exist. None of you have absolute proof that I'm speaking in front of you right now. On the other hand, I would argue that you can develop with the tools of science a probability that I'm speaking in front of you right now. And the question is, what is that probability, and what kind of uncertainty do we have the fact that I exist, and we can apply this to the designer. What is the probability that the designer is Jesus Christ? And then we can ask a couple of questions. Is the uncertainty about our identification of the designer, and there could be different models with different designers identified, is that uncertainty getting progressively smaller, or is it getting progressively larger as scientists learn more and more about the record of nature? Then the second question, has science developed to the point where the uncertainty is small enough to eliminate the alternatives that are competing with your model? Now, there are those who will argue that doesn't this violate the church-state clause, the separation of church and state? Well, I would argue that what we see in the First Amendment of our Constitution is that it guarantees the freedom of religion. It is not guaranteeing the freedom from religion. It's not a Soviet-style system where the only religion permitted is that of atheistic materialism. It's the freedom of, not the freedom from. However, the way it's been practiced is it prevents a federally supported denomination, not at a state level, though the states have chosen to follow suit. Also, we need to note that from the very beginning of our nation, the state has always discriminated against failed religious models. 200 years ago, you didn't see the state sponsoring educational programs based on a flat Earth or based on the concept that the Earth was the center of the solar system rather than the sun, in spite of the fact that both concepts are loaded with a lot of religious baggage. The state has always done it where the evidence is overwhelming that it's a failed model. And particularly with the Supreme Court case on the equal access point, they made it quite clear that access to models with scientific integrity and credibility is valid regardless of the theological implications. What you see in the 4 court cases of the past 50 years is the standard of measure was how credible, how valid, what degree of integrity we see in the science that's behind the religious concept. And if that's there, it has access regardless of its theological implications. Therefore, I would conclude that teachers should tolerate all creation evolution models, but train students to use the scientific method to distinguish failed models from successful models. I was educated in Canada, and we did that. I mean, our teachers trained us to use a scientific method to figure out why, for example, geocentrism wasn't an acceptable hypothesis, in spite of its religious implications. And we need to recognize that the scientific method is structured in such a way that it's a brutal competition among ideas. And maybe one thing we can do within the intelligent design camp is to really strive for more brutality, more competition, but to make sure that it's a free market competition, a level playing field where we can actually encourage the competition to become more brutal rather than less brutal. Now, there are several tests that I'd like to suggest for where we can make some progress on this creation evolution front. I just kind of picked out 10 tests that probably have the greatest potential for making progress in light of how fast science is advancing in these different disciplines. And I start from the simple sciences and move to the complex sciences. What is the evidence that the cosmic origin event is from a transcendent causal agent? Is there really significant fine-tuning in the different laws of physics and the features of the universe? Do we see that in the solar system? Robin's already addressed a lot of this. How about the origins of life? Maps of biomolecules? The speciation extinction model. I heard this last night from William Provine. We need a model to explain both extinctions and speciation. This is something we've been doing at Reasons to Believe. You'll see it in a number of our books. In fact, the closing chapter of our latest book, The Origin of Life, gets into speciation extinction models. And the 6th point here, the 7th point, mass extinctions and speciations. There's both mass speciation events to accompany the mass extinction events. Fuzz, later this afternoon, will speak about biological convergences. And really, in my opinion, the answer to why we see extinctions in the fossil record and speciation events is something we call a faint sun paradox. How the sun starts off quite bright, loses mass and becomes dim, but as hydrogen burning progresses, it becomes brighter and brighter, and that's continuing to this day. And it's critical from a creator's perspective to create just the right life forms at just the right time, and just the right diversity and just the right abundance to perfectly compensate for the changes that are taking place in the physics of the sun over the past 4 billion years. And then also Bill Provine made comment about the DNA history of primates. This is something that Fuzz and I are addressing in a future book that'll be coming out next year on the origin of humanity, and we have several chapters there that deal with that point. Well, I'm going to just take the time today to deal with the first 3 tests that we're recommending. And, I go back a ways. I started studying astronomy seriously when I was 7 years of age. And the first book I ever read on astronomy was a book on cosmology by Sir Fred Hoyle. And in that book that he published back in 1952, he conceded in the opening chapter that we do see a lot of cosmology in the different holy books of the religions of the world. But there's one holy book that outweighs all others in terms of its cosmological output, and that's the Bible. In fact, Fred Hoyle, and this is interesting because he's coming from a pantheistic perspective, said of all the holy books, the Bible is amazing in the quantity and the quality of its content on cosmology. Well, there's three things that you see as you go through the different chapters of the Bible, the different creation accounts of the Bible. There are 20 major creation accounts in the Bible, and as you put them together, you see that there are three basic claims the Bible makes about cosmology, the origin and structure of the universe. Namely, that the universe has a singularity beginning. That's a physics technical term for a beginning of matter, energy, space, and time, a coincident beginning of matter, energy, space, and time. The Bible actually speaks more frequently about how the universe has a condition of being continually expanded from the creation event, undergoing continuous expansion from the beginning through the present into the future, and how as the universe gets older and older, it gets progressively colder and colder. Now, what's interesting about these three claims is that this is the heart of all modern cosmological models. But keep in mind that modern cosmologists did not discover these features of the universe until the 20th century. We have Bible authors dating back 3,500 years that made these statements about the universe thousands of years before any scientist or philosopher conceived of these cosmic concepts. This is an example where the Bible predicted future discoveries thousands of years ahead of its time. Now, just a clarification on the first point. What is this singularity beginning? A lot of misconceptions both in and outside the church what this singularity beginning from a biblical perspective or a scientific perspective is all about. These are some things that it's not. It's not a primordial egg. It's not some primordial atom that disintegrates. It's not a point. The universe does not grow from a point. Rather, it grows from an infinitely shrunken volume that can have many dimensions. It's not a chaotic explosion. Rather, we see in the expansion of the universe the greatest evidence for fine-tuning design we find in any of the scientific disciplines. It's not the filling of a volume. Rather, the universe expands where all the matter and energy is on the surface of the universe, the three-dimensional surface of the four large dimensions that describe the universe, ignoring for a moment the six tiny ones that accompany the four big ones. And it's not evolution from hydrogen gas. In fact, the universe doesn't even start off with the hydrogen gas. That comes later. Now, in terms of what the Bible's got to say about this cosmic singularity beginning, it begins with the first sentence of the Bible, in the beginning God created, the Shemayan Eres. That's a compound Hebrew noun that refers to the entire physical universe, including matter, energy, space, and time. The word bara means to create something brand new that did not exist before. Hebrews 11:3 says the universe that we can detect was made from that which we cannot detect. And the Apostle Paul, I don't have his verses up here, actually makes specific references to the beginning of the universe being the beginning of time and space itself. And really there's no doubt about this in terms of Bible theology, Christian theology. The universe abundantly claims that the Bible abundantly claims that the entire universe is traceable back to a moment when you've got God bringing into existence matter, energy, space, and time, and God does that independent outside of matter, energy, space, and time. Now, the first inkling of this from a scientific perspective dates back to 1970. This paper I have before me here, Stephen Hawking and Roger Penrose, they won the Wolf Prize in Mathematics for this groundbreaking paper. 1970, the singularities of gravitational collapse in cosmology. And what they pointed out in this paper, it's a mathematical theorem that says if the universe contains mass, and if the equations of general relativity reliably describe the dynamics of the universe, then there must be a beginning to matter, energy, space, and time. Now, hidden in this paper is a significant corollary that doesn't get nearly the publicity it deserves. A corollary to this mathematical theorem states that if the universe contains mass, and if the equations of general relativity reliably describe the dynamics of the universe, there must exist a causal agent that brings matter, energy, space, and time into existence independent of matter, energy, space, and time. Now, this is something that the Bible stands alone in terms of the different holy books of the religions of the world. You know, Christians believe not just in a cosmic creation event, but on a transcendent causal agent, a being who creates independent or outside of matter, energy, space, and time. Now, when this paper was published in 1970, it was limited in the context of what's called classical general relativity. And years later, there were theoreticians who said, well, what about quantum gravity models? And this is the idea that when the universe is extremely young, younger than 10 to the minus 43 seconds, that there might be different quantum laws that could give us different models of the universe. And I've been documenting this in my latest edition of The Crater and the Cosmos, that what's been happening in the last 3 years is that theoretical physicists have begun to explore the full range of space-time theorems of general relativity. And what they've been able to come up with is that all reasonable models, and what they mean by reasonable models is models of the universe that are subject to the second law of thermodynamics. Now, if you don't believe in the second law of thermodynamics, you've lost all bases of reality. Causality goes out the window, and that's something that our patent office practices. If you come in there with an invention that violates the second law of thermodynamics, they show you the door. Well, that principle also works in science. I mean, if you're going to violate the second law of thermodynamics, we'd really have to show you the door. Excuse me here. What we're seeing is that these theorems are becoming generally more applicable, and what I haven't discussed is that the strength and numbers of general relativity proofs are growing. I mean, what is the evidence that the universe really is ruled by the equations of general relativity? Probably you heard in the news that they've just sent up a few days ago here in California what's called the Gravity Probe B experiment. And really what that is an attempt to test the theory of general relativity in the only remaining place where it hasn't been subjected to a really rigorous test. Now, the best tests of general relativity I could refer you to would be binary neutron stars, or actually the better test is where you got a binary pulsar. These would be two pulsars that are orbiting one another so closely that their mutual gravity is causing them to slowly spiral into one another and merge. That's a prediction of general relativity, that if you've got two very dense bodies orbiting one another closely, they will spiral together and merge, as distinct from other theories of gravity. And just a few months ago, astronomers discovered the first close orbiting binary pulsar. And the wonderful thing about the binary pulsars is you've got two bodies that are extremely dense. A typical neutron star, the density comes in at 5 billion tons per level teaspoonful. So when you've got a cup of coffee, you might want to think about a level teaspoonful weighing 5 billion tons. What's that going to do to your coffee? What's that going to do to your diet? But the other thing about pulsars is that they're wonderful clocks. Every time a pulsar goes around once in its orbit, it shoots out a pulse of radiation in our direction. And the one that they discovered back in January, we see these two stars going around one another, and they're both sending out pulses several times per second. So you got two excellent clocks orbiting one another where you got gravitational fields 1,000,000 times stronger than anything we can measure in our solar system. And what has happened last January is that astronomers have been able to confirm that general relativity reliably describes the dynamics of the universe now to 15 places of the decimal. General relativity today, as I describe in The Crater and the Cosmos, ranks as the most exhaustively tested principle in all of physics. There is no other principle of physics that has been subjected to more extensive and broad testing than the theory of general relativity. The last one to be done is the lens-Thirring effect. So far, that's only been confirmed to 10% precision with the Lagos satellites orbiting planet Earth. But this Gravity Probe B is going to push it to several more places of the decimal. Thanks to your tax dollars, we're going to be able to look forward to, quote, the last definitive test of the theory of general relativity. But I'm here to predict it's going to pass the test. It's going to pass the test just as well as the other tests have done. Now, this allows us to make some predictions here. This is Redound Fakir's comment, and this is interesting because as a theoretical physicist, he comes from a non-theistic perspective. and yet he wrote in his paper, all reasonable cosmic models are subject to the relentless grip of the space-time theorems of general relativity. Now, when I give this talk in front of astrophysicists, I get just one rebuttal from the audience, and it's probably a rebuttal that many of you have heard. Well, if God created the universe, who created God? And, it's great that you can explain how this universe was created by God, but I'm not going to really be satisfied until you explain to me who created God. By the way, it's not original to theoretical physicists. As I teach Sunday school at our church, I hear kids that are 3 years of age asking the same question. It seems to be a question that everybody wants to ask. But in the context of an audience filled with astrophysicists, what you can do is simply take them right back to the space-time theorem of general relativity. What Hawking and Penrose demonstrated was that there must exist a causal agent that brought this universe of matter, energy, space, and time into existence without the benefit of cosmic time. Now, if you survey the scientists here in the audience, and there's lots of them in many different disciplines, what they'll share with you is that the most consistent definition for time, or a working practical definition of time, is that dimension or realm in which cause and effect phenomena take place. So what we get from this space-time theorem of general relativity is that this transcendent causal agent, at a minimum, must have access to the equivalent of 2 dimensions of time, 2 different realms in which cause and effect phenomena can take place. And in that sense, we could conceive of time, for example, in the context of the creator of the universe, as being like a plane, where you've got a length of time and a width of time. And in such a plane, you can have an infinite number of lines running in an infinite number of directions. And therefore, you could have the creator existing on a timeline here that's infinitely long, that never crosses or touches the timeline of the universe over here. As such, that being would have no beginning, no ending, would be uncreated. And as I described in Beyond the Cosmos, it's also a being that in our time context could arbitrarily expand time or shrink time. These are statements that have been in the Bible for thousands of years, but they're statements from a mathematical perspective that could only be true of a being who has access to at least the equivalent of 2 independent dimensions of time. So in that context, there's no beginning, there's no ending. He is not created. Now, 5 predictions I'd like to make for the future, short-range predictions. I would predict that the case for a single cosmic beginning will grow stronger and stronger as we learn more and more about cosmology. That the case that time is finite rather than infinite, or that time is relative rather than absolute, will also get stronger and stronger as we learn more and more about the universe. That the case for general relativity, reliably describing cosmic dynamics, will mount. Now, I want to be clear. It's quite possible that when we measure or test general relativity to 25 places of the decimal instead of 15 places of the decimal, we may find new additional laws of physics that operate at that level. But those conclusions, or that kind of discovery, will not disturb the evidence we already have that general relativity reliably describes the dynamics of the universe. After all, NASA sends spaceships to Mars without ever taking into account the general relativistic corrections. They're simply not big enough, so we can reliably send spaceships to Mars without taking into account general relativity. And already the measurements are in place telling us that general relativity really does reliably describe the dynamics of the entire universe on both small scales and large scales. I would also predict that as theoreticians continue to develop and generalize the space-time theorems of general relativity, we'll discover that their grip will become progressively more and more relentless, and that the case for a transcendent causal agent will mount with time. Now, why am I saying this on a talk about intelligent design? I'm saying this because often when I speak in front of scientists, they are coming from a perspective that miracles never happen. And if you have that as a foundational belief, then no matter what kind of evidence you present for supernatural design, it will be rejected. And so a good way to start is say, well, in terms of just where did the universe come from, we have here evidence that we have at least one incontrovertible miraculous act. I give the example here of a scientist who doesn't believe that murders happen. How do you convert him? Show him one murder. If he never sees one murder, he may never be persuaded that his presupposition is incorrect. Same thing with a cosmologist. The problem is not the lack or the quality of design evidence, but an anti-supernatural bias. How do you remove that anti-supernatural bias? Provide proof for one transcendent act. Then at least you've got to be open to the possibility that this transcendent causal agent may have acted at other times beyond that. Now, I'd like to get to the second cosmological point. As I mentioned earlier, the Bible actually says much more about the continuous expansion of the universe than it does about it having a transcendent causal singularity beginning. And this isn't a total list of verses, but it gives you a smattering. Two of them make the point that God alone expands the universe. God alone stretches out the heavens. 7 of these passages put it in the Cal participle form, which means that God on an ongoing continual basis is expanding the universe. 3 passages put it in the Cal perfect form, which means that when God created the universe in the beginning, he created it with those laws of physics that would guarantee ongoing continual expansion. And then 2 of these passages talk about the expansion of the universe as being likened to someone unfurling a tent. The point there being the reality of the tent is the surface of the tent, not the interior or the exterior. Likewise, modern cosmologists have recognized all the matter and energy is distributed on the surface of the universe, rather akin to what we see on planet Earth. Where do the people live? They live in the 2-dimensional surface of the 3-dimensional Earth. Likewise, the stars and galaxies, matter and energy, is on the 3-dimensional surface of the 4-dimensional expanding universe. But the Bible said it thousands of years ago before any scientists came upon this discovery. Now, in terms of this evidence for the stretching out of the heavens, particularly the statement made by Job that God alone is responsible for the stretching out of the heavens for the benefit of life and human beings in particular, I'd like to take it back a few years ago. The chairman of the Physics and Astronomy Department at Case Western Reserve University published this paper back in 1998 in the Astrophysical Journal, where he predicted that astronomers would soon discover a dark energy term governing the expansion of the universe. And he said, when this is discovered, it will present us, and this is a direct quote, with the most extreme fine-tuning problem known in physics. Now, if you know Lawrence Krauss, he's coming from a non-theistic perspective. He's on television quite frequently now. And from an atheistic perspective, this indeed would be a problem, because what he points out in his paper here is that you really would have to fine-tune not only the dark energy term, but the mass density term if you want the kinds of stars and planets that would make physical life possible at some time in cosmic history. And just to kind of give you a feel for it, if you expand the universe too quickly from the beginning, bits and pieces of matter will fly apart at such a high rate that gravity will never have the opportunity to drag together enough matter to condense into galaxies, stars, and planets. The universe would be forever gas. And in such a universe, life would never take place. On the other hand, if you expand the universe too slowly, the bits and pieces of matter will coagulate under gravity with such extreme efficiency that in a relatively short period of time, all the mass of the universe would be in the form of neutron stars and black holes. And we're talking a minimum density of 5 billion tons per teaspoonful. Molecules and atoms are impossible under those conditions. So either way, you don't get life. You got both an upper bound and a lower bound. And then Krauss goes on to describe what those upper and lower bounds are. And he points out in this paper that in order to get the kinds of heavenly bodies that would make physical life possible, it's necessary that the mass of the universe, the mass density of the universe, must be fine-tuned to within 1 part in a trillion, 1 part in 10 to the 60th. Make it slightly bigger, slightly smaller, no possibility for life at any time in cosmic history. And with this dark energy term, which is basically a description of the self-stretching property of the surface of the universe, one way I could describe it is to say it's an anti-elastic band effect. If I stretch an elastic band, the elastic band gains energy to force contraction. The way dark energy works is at the surface of the universe, where all the matter and energy exists, as it expands from the creation event, gains more and more energy to thrust forward more rapid expansion. So here's the picture. When the universe is very young, it is very small, hasn't expanded much from the creation event, and therefore gravity is powerful in trying to slow down the expansion of the universe. But as the universe gets older and older and gets bigger and bigger, gravity becomes progressively weaker and weaker in its capacity to slow down cosmic expansion. On the other hand, as the universe gets older and older and gets bigger and bigger, this dark energy becomes stronger and stronger in its capacity to thrust forward more rapid expansion of the universe. In a paper that's been published, you'll see it posted on our website at reasons.org on our Today's New Reasons to Believe, is that astronomers now have measurements to determine that the universe has been slowing down under the influence of gravity in terms of its expansion for the first 9 billion years of its history, but for the past 5 billion years of its history, it's been speeding up. And as the future proceeds, the universe will expand at a more and more rapid rate. Well, this paper was posted on the Los Alamos website as a preprint, a couple of years ago now, and is written by 3 atheist theoretical physicists, 2 from Stanford University and 1 from MIT. But they chose an interesting title. It's called Disturbing Implications of a Cosmological Constant. Now, if you look at the preprint, there's a couple of quotes here that I want to alert you to. One is, they say, arranging the universe as we think it is arranged, that is, with a dark energy term and a mass density term, would have required a miracle. Rather interesting statement to come from 3 atheists. And then they go on to say, an external agent, external to space and time, intervened in cosmic history for reasons of its own. Now, as atheists, they considered these 2 conclusions to be so very disturbing that they concluded their paper, and I'm going to read you the last sentence in their paper. They said, quote, "The only reasonable conclusion is that we do not live in a universe with a true cosmological constant, a true dark energy term." They said this is so radically disturbing, the dark energy term must be wrong. Now, the irony about the posting of this preprint is it was posted just 10 days before we have NASA and the people working with the Sloan Digital Skies Survey coming out with their latest measurements in the dark energy term. You know, back in 1999, it was measured to maybe about plus or minus 20% precision. But what happened in 2003 is that it got measured to 1% precision and was measured by 4 independent observing techniques. And in 2004, a 5th technique was added. In fact, Science magazine, the publication of the American Association for the Advancement of Sciences, declared the accurate measurement of dark energy as the greatest scientific discovery for 2003. We now know that it accounts for 73% of the total density of the universe, plus or minus 1%. The whole point is, in spite of this being so very disturbing, it's not going to go away. The evidence for this dark energy term is getting greater and greater as time goes by, rather than lesser and lesser, which means we really are stuck with a conclusion that this transcendent causal agent must be a personal being that's performing miracles for reasons of his own. Or to put it another way, we can take this 1 part in 10 to the 120th, and by the way, there's some astronomers that believe that the fine-tuning is really at the level of 1 part in 10 to the 240th. 240 zeros after the 1. So without doubt, it is the most profound fine-tuning evidence that we have. But if you just take the 1 part in 10 to the 120th, and let's compare that with the very best example of human engineering design. And if you were to press me on that, I would guess that the best example we have is a gravity wave telescope that's been recently put into operation by Caltech and MIT physicists. This instrument is incredible. Thanks to your tax dollars and the brilliance of these MIT and Caltech physicists, this machine can make measurements to 1 part in 10 to the 23. But that 1 part in 10 to the 23 is 10 to the 97 times inferior to 1 part in 10 to the 120th, which allows us to draw some interesting philosophical conclusions, namely that this transcendent causal agent that brought into existence matter, energy, space, and time 13.7 billion years ago, at a minimum must be 10 trillion times more intelligent and more knowledgeable than those Caltech and MIT physicists. And at least that many times better funded. So what we've demonstrated here is it's not just a causal agent that transcends space and time, it's a causal agent that's a person, because only a person can manifest the qualities of intellect, knowledge, creativity, and power. But the fact that we can prove at a minimum that it's far beyond the limits of what we human beings are capable of performing really does give us a powerful argument that we're talking about the God of Christianity rather than the God of Hinduism or Buddhism or Islam, a God that describes himself as being very intimately involved with his creation. Now, there has been some speculation of sorts from scientists who are concerned that we have this huge amount of design evidence in the mass density and dark energy term. Is there a way we can reduce that with alternate physics? And this comes under the title of quintessence, speculation that one or more constants of physics varies in such a way as to substitute, at least in part, for the dark energy term or the mass density term. But if you're keeping up with the literature, and if you're not, you can go to our website. We've been posting the discoveries on our website. What they now concede is that all possible quintessent factors either retain or enhance the cosmic design. And the latest supernova measurements that have been made, this again has just been published in the last month, demonstrates that if there is any change going on throughout cosmic history in the dark energy term, it's at quite a low level. But I would concede that it's possible if you measure it accurately enough, you might find a tiny you might find a new constants of physics that would allow for a small amount of variability. But the problem was it doesn't get rid of the design. You're simply trading design for design, or in some models, you wind up increasing the level of design. Now, as you heard from Robin Collins, what we're discovering is that there are many factors that we measure in the universe and the laws of physics that show design. And in most of these factors, we have both an upper bound and a lower bound, and the difference between the upper and lower bound is quite tiny. Number 5, for example, if you want to get the full panoply of stars and planets that would make life possible, you have to fine-tune the ratio of the electromagnetic force to the gravitational force to better than 1 part in 10 to the 40th. 10,000 trillion. And so it's not just the mass density and the dark energy density terms that need this very exquisite fine-tuning. This is again posted on our website, so I'm not going to dwell on this in great detail. I think I've got, I'll have to find out. Yeah, there are 50 here. Okay, and I prepared these overheads 6 months ago. If you go to our website today, yesterday we posted our latest update on these laws of physics and constants of physics and gross features of the universe that must be exquisitely fine-tuned to make any kind of physical life possible any time in cosmic history. The new list that we posted yesterday, 65 characteristics. And we give you all the references to the peer-reviewed literature so you can check out for yourself exactly what are the measurements that support these conclusions. But the whole point is in 6 months we've gone from 50 characteristics to 65 characteristics. A prediction here is that if we're right about the God of the Bible being responsible for designing the universe for the benefit of humanity, the more we learn about the universe, the stronger that evidence should become. So we would expect that this list would grow in number, and the fine-tuning would prove to be more and more impressive as we learn more and more about the universe. And that's certainly been the track record of the past 40 years of research in physics and astronomy. My first book, The Fingerprint of God, published in 1989, I listed 15 characteristics. We now have 65. Now, what kind of reaction do we get from the astronomers who take a non-Christian perspective? I got some quotes here. This is one from Fred Hoyle. I use him because he discovered 4 of these 65 characteristics and wrote a paper about it called The Universe. And he was the one that discovered that you have to exquisitely fine-tune the nuclear ground state energy levels of helium, beryllium, carbon, and oxygen, independent of one another, to better than 5%. And as Robin mentioned, we now have new research that indicates that the fine-tuning is even greater than that. But Sir Fred Hoyle back in the 80s said, consequently, the only conclusion we can draw is there must exist a super intellect who has monkeyed with the physics as well as with the chemistry and the biology, a decidedly non-Hindu conclusion to draw. And then George Greenstein, he's coming from an agnostic perspective, but wrote a book a few years ago called The Symbiotic Universe. As we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency capital A, must be involved. And in Paul Davies' book, The Cosmic Blueprint, it seems as though somebody has fine-tuned nature's numbers to make the universe. And the second to last sentence in that book, the impression of design is overwhelming. Now, when I was a graduate student, I had as a professor during the summertime Jeffrey Burbage, and he gave a series of lectures on cosmology, and I made it quite clear that he is a committed and an aggressive atheist. And when astronomers came out in the 1990s with definitive evidence that we live in a Big Bang universe that's traceable back to a cosmic singularity event, he made a statement to the Toronto Globe and Mail, and this is what he said. Said, astronomers have rushed off to join the First Church of Christ of the Big Bang. And I quoted that on a radio show the day after he'd said that to the Toronto Globe and Mail, and I got a phone call from him and says, well, do you realize I'm an atheist? And I said, yes, I took your course. And then I asked him if I could have permission to quote this in The Crater in the Cosmos, and so he has granted me permission to put that quote in the book. But I do make it clear that he is coming from a non-theistic perspective. And it's basically a complaint that with all this evidence for the Big Bang creation event, indeed there's been this rush of astronomers to join this new church, the First Church of Christ of the Big Bang. Now, while it is true that there is a consensus, or at least a growing consensus amongst astronomers and physicists who do research and looking at these characteristics of the universe and measuring their fine-tunedness, and this is documented in a number of books that Robin Collins has already referred to, and I actually devote an entire chapter in this book to quotes from astronomers who've done this kind of research, there is this consensus where they agree with Paul Davies, overwhelming evidence for design. So in that sense, or at least in that discipline, the debate over design has been settled. However, what's not been settled is who or what is a designer. Most of my peers who've done research in this discipline would strongly argue it's not the God of the Bible. They would argue for design and a designer, but they're looking at alternatives. But there's really 3 arguments that they propose for why it can't be the God of the Bible. One of the more famous ones is attributable to Stephen Hawking and to Carl Sagan. In the book A Brief History of Time, at least the first 2 editions, they made the statement that the Christian God can't be responsible for the universe because as you read the Bible, what we see is a God that doesn't waste miracles. God performs as few interventionist miracles as possible to fulfill his purpose, and they argue that the Christian God would not make so many useless stars and galaxies. After all, if you want human beings, all you need is one star and one planet, a moon, some other planets, some gas and dust, and that's about it. And so the existence of 100 billion, trillion useless stars, they claim is proof that it's not the God of the Bible. Well, you've already heard me address that. The mass density of the universe must be tuned to within 1 part in a trillion, 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 or you're not even going to get one star and one planet. The universe, in other words, must take on exactly the mass that we observe that it has in order for there to be the possibility that you're going to get the right kind of star and planet and moon in which life would be possible. Just in terms of the elements you need. If the universe isn't massive enough, all you get is hydrogen. If it's too massive, all you get are elements heavier than iron. It's got to be just right in order for life to be possible. Now, a very common rebuttal 15 years ago is to say, well, We wouldn't be here unless the universe had the attributes we observe. I deal with this in The Crater and the Cosmos, borrowing an argument that was Richard Swinburne. And I love what Richard Swinburne said. When physicists get philosophical, you have to rebut their bad philosophy with philosophy. And what he commented on was, he basically came up with an analogy. He said, what we could do is we could take an audience like this, and I'll bet you quite a few of you are from the South, and probably are pretty good at the use of firearms. So we could probably find 10 people here in the audience who are sufficiently skilled with firearms that we could put the 10 of them up here in front, give them a high-powered rifle with a telescopic sight, and then we'll ask for one volunteer from the audience. We could take this lady here, ask her to come up in front, and she'd be 15 feet away from these 12 sharpshooters, and then we instruct the 12 sharpshooters to pull their triggers and kill her. Now, she survives the event. So she looks out at all of you and says, well, of course, I wouldn't be here to see all of you unless they all missed. And Richard Swinburne's comment is, that's not what would come out of her mouth. What would come out of her mouth is, why did they miss? In other words, the appropriate conclusion to draw is that someone must have purposed that she would survive to explain the fact that she is able to make that comment. In other words, someone either put blanks in all their guns, or those 12 individuals all decided on purpose to miss shooting their bullet through her heart. That explains it. Likewise, he says, this fine-tuning of the universe can only be explained by the fact that someone's out there who has a purpose for life existing in human beings in particular. But as you heard from Robin, the most common explanation of all is that, at least now, because of Richard Swinburne, the other two are gone, so we're left with this one, that the reason why the universe has these incredibly fine-tuned characteristics is namely that there's an infinite number of universes out there, all having different physical characteristics, and ours is a universe that by pure chance has all these highly fine-tuned characteristics that would make life possible. Now, I've written in my book, The Crater and the Cosmos, that this is simply a form of the gambler's fallacy. And the way I could help you see that fallacy is I got a Canadian nickel here, and I'm going to flip it. Okay, it came up beavers. In Canada, the nickel doesn't have heads and tails. It's got the queen's face and a beaver on the other hand. Okay, what if I were to flip this nickel 100,000 consecutive times, and it came up beavers all 100,000 times? What would you conclude about the physics of this coin? Okay, would you be willing to bet heads on the next flip? Now, if you're committing the gambler's fallacy, you would rationalize as follows. Well, this is one coin. Outside of this auditorium, there could exist a huge number of coins. What if outside this auditorium, there exists 2 to the 100,000 coins being flipped by 2 to the 100,000 people? Now, just so you can appreciate what I'm talking about, it's 2 times 2 times 2 times 2. You multiply that out 100,000 times. It's truly an enormous number. 2 to the 100,000 coins being flipped by 2 to the 100,000 coin flippers 100,000 consecutive times each. The laws of probability tell us that one of those instances would come up by chance 100,000 consecutive beavers. And so the individual would say, I'm going to bet heads because it's a fair coin. Just because I saw 100,000 consecutive heads doesn't prove anything. We call it the gambler's fallacy because that individual has no evidence that that many coins exist, has no evidence that 2 to the 100,000 people are flipping 2 to the 100,000 coins 100,000 consecutive times each, and especially has no evidence that they're producing distinct results. And so when you see a coin coming up heads 100,000 consecutive times, in fact, I would argue, if you see a coin coming up beavers 10 times in a row, that already is enough evidence that has been purposed to always come up beavers rather than heads. 100,000 times, it's a certainty. Now, I've made this point in front of audiences exclusively made up of astronomers and physicists and mathematicians, and several of them, coming from a non-theistic bias, would say, you know what, I understand your argument, but because this God of the Bible makes such huge demands on our personal lives, I'm going to stick with the gambler's fallacy. I know it's a long shot, but I'm going to go with it anyway. Now, my response to those individuals is say, well, I can understand why you might want to do that because the God of the Bible does make significant demands on the lives of all individual humans. But wouldn't you at least like to examine this coin ahead of time before you gamble your life on heads on the next flip? Wouldn't it be a good idea to pick up the coin and see if there's a beaver on both sides? In which case, you don't have to take a risk. You know what's going on. Or maybe you could check to see if it's been weighted to always fall beavers rather than heads. And they say, you can't do that with the universe. Well, my response is, yes, we can. Every day, astronomers are learning more and more about the universe. As we learn more and more about the universe, we're discovering more and more of its features, our explanatory capacity to explain the different phenomena of the universe is growing with time. In fact, the doubling time for research in astronomy is about 3 years. Every 3 years, we learn twice as much as we did before. So there's abundant opportunity to examine the coin in greater detail. As we examine the coin in greater detail in the next few weeks, the next few months, the next couple of years, if we discover that the evidence for purpose and supernatural design gets progressively stronger and stronger rather than weaker and weaker, that should be adequate to prevent the individual from committing the gambler's fallacy, if they're thinking along irrational lines. Of course, we always have to give people the right to be irrational, but I don't think we have to give them the right to claim that what we say is rational is irrational. Now, one of the ways to put this to another means of testing, again, is something that Robin suggested. We can go from the design of the universe to the design of our galaxy and our solar system. And when you do that, you discover what astronomers have called the heavenly body problem, that it's not just any old galaxy that will be a candidate for physical life. You need the just right galaxy, the just right star. You got to have Jupiter, and it's got to be just the right size, just the right kind of orbit, just the right distance. Obviously, you need the just right planet, and there's a book written a few years ago called What If the Moon Didn't Exist, an entire book talking about the fine-tuning of the different characteristics of the moon that makes life possible, uniquely possible on planet Earth. So these need to be addressed. And what we discover with a galaxy, for example, you don't want a giant galaxy, because a giant galaxy is going to have a big black hole that will be spewing out lots of nasty radiation. And there'll be other gravitational problems with living in a giant galaxy, but you don't want to be in a medium-sized or small galaxy either. The only one that's going to work is what we call a medium-large galaxy, about the size of our Milky Way galaxy. It must be a spiral galaxy, a galaxy that retains spiral structure for billions of years. A spiral structure that's not fettered with what we call a lot of spurs and feathers in its structure. And only a few percent of the galaxy in the universe meet that requirement. It must be a medium-large spiral galaxy, not too fettered with spurs and feathers, that happens to have the right neighborhood. You want it to be in a small cluster of galaxies where the galaxies are relatively far apart, where there's no giant galaxies in the vicinity, but lots of dwarf galaxies that can be gobbled up to sustain a spiral structure for a long time. That's our local group, 24 members. Most galaxies find themselves in clusters that have 10,000 plus members. We live in this local group, 24 members at the extreme outer fringe of the Virgo supercluster. It also must be a galaxy that's existing in an area where you got the just right intercluster medium, the gas that exists between the galaxies, and just right location of the universe. And when we look at the solar system, just to get the elements that are necessary for advanced life, you need the solar nebula to form right next to a type 1 supernova, not too close, because if it's too close, the solar nebula gets blown apart, but if it's too far away, it doesn't absorb enough of these life-essential heavy elements, and of course, the timing must be just right. It must be at just the right time in the history of the condensation of the solar nebula. That's also true for the type 2 supernova, and a brand new discovery. You'll see it posted on our website, indicates that you need a standard type 2 supernova and then an extremely rare kind of type 2 supernova. Standard type 2 supernova do not make all the elements we need for life. There's a very rare kind that makes a few elements that are critical for existence. And again, a brand new discovery, this is a month old, that gamma ray bursts play a critical role in producing 4 elements. 2 which are critical for life, the zinc and the copper. There are 2 isotopes that are made by these gamma ray bursts, the 2 most common isotopes, but also titanium. That you need the right z-axis displacement of the solar system. The solar system orbits around the center of the galaxy, but if it goes up or down in the plane of the galaxy too much, it gets exposed to nasty radiation, which could be a problem, at least for advanced life. The spiral arm distance must be just right in terms of the elements that are necessary for life, and also the safe zone where our solar system can orbit around the center of the galaxy without being disturbed by big gas clouds, molecular clouds, dust clouds, and the spiral arms. And clearly the star must be just right, and you need the just right planetary partners. Something's being discovered as we find planets outside of our solar system is that really almost all the planets of our solar system must be exquisitely fine-tuned to sustain life on planet Earth for as long as the geological history tells us. In terms of the Earth itself, it's got to be just the right size, just the right distance from the sun. These are 2 things that Carl Sagan pointed out back in 1963. Something relatively new. It's critical that our Earth receive a collision from a body the mass of Mars at a particular time in its cosmic history, 70 million years after its formation. It must hit at just the right spot, not head-on, not glancing, but in between, in such a way that the heavy element material from the collider gets absorbed into the Earth in order to give the Earth the radiometric elements that are necessary to drive the plate tectonics that form the continents and enable planet Earth to have the life forms at just the right time, just the right sequence to compensate for the increase in the solar luminosity, and also to give us a just right atmosphere. If it wasn't for this collider, we would have been condemned to live on a planet with an atmosphere 100 times as thick as the one that we enjoy. Venus, for example, which didn't get a collision, has an atmosphere 40 times as dense as ours. Thanks to the collision, we get just the right mass to sustain water on the planet for a long period of time, but we don't get the atmosphere that would have made advanced life impossible. Now, back in May of 2002, what we did at Reasons to Believe is our scientific team looked at all the different characteristics that manifest fine-tuning in the context of our galaxy and our solar system. And we found there were 202 such characteristics. And the probability that all 202 would be met if you multiply them together would be 10 to the minus 265, less than 1 chance in 10 to the 265. But we noticed that not all of them were strictly independent. There were dependency factors that were quite significant. Somewhat counterbalancing that are longevity requirements. Many of these factors have to be kept at a particular level for very long periods of time. And then, as you heard, there could be a lot of planets. Well, in terms of the observable universe, the maximum number comes in at about 10 to the 22, which gives us less than 1 chance in 10 to the 217 that you're going to find one body existing anywhere in the observable universe without invoking divine miracles. That was May of 2002. Just last week, I went through all of our research on our website and in our files at our office to give an update. And here's what we come up with. In the last little less than 2 years, we've gone from 202 characteristics to 323 characteristics that must be fine-tuned, with a probability now of 1 chance in 10 to the 388. The dependency factors, and here we decided to be as generous as we possibly could. We came up with dependency factors that would lower that probability by 10 to the 96. Longevity requirements, and here again we're being as conservative as we possibly could, 10 to the minus 14, which gives you a probability of 10 to the minus 304, and with 10 to the 22 planets maximum in the observable universe, we have less than 1 chance in 10 to the 282 that you're going to find one body existing anywhere in the universe. Now, this is all posted on our website. In fact, what you'll see on our website is we post our research of the past 4 years. So you can see for yourself over a 4-year window how much stronger the evidence has been coming with each passage, each year that goes by. Or to put it in another context, I first wrote about this in 1989, where we had 26 characteristics described for the solar system in our galaxy. Today, it's 323. This is also available in hard copy. We got a list for the universe, 65 characteristics. And then we've picked out a list for the galaxy in our solar system where we got a strong upper limit and a strong lower limit. And again, back in May of 2002, I had 118 such factors of the solar system and galaxy where we had this narrow window between the upper limit and the lower limit. The latest one we got, 154. So we've gone from 118 to 154 in a little less than 2 years. Then the probability calculation is here. I got 2 or 3 copies of this if you want it, but it's all posted on our website and is downloadable. Take advantage of that. If you're not having access to the web, contact us and we'll get you a hard copy. But the bottom line is this. In a little less than 2 years, the evidence that a supernatural being, as we see described in the pages of the Bible, is responsible for designing the solar system and our galaxy for the benefit of life and human beings in particular, has become more than 10 to the 63 times stronger. Where else can you go in apologetics and get a factor of 1 trillion, 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 trillion in less than 2 years? And what we've seen over the past 15 years is that you can add at least a factor of 1 billion with every 6 months of astrophysical research. So the evidence for the God of the Bible is getting 1 billion times stronger with every 6 months that goes by, which gives us a wonderful opportunity to appeal to those who come from a non-Christian perspective. Wait 6 months and see what happens. If it gets 1 billion times stronger, then you need to seriously consider our creation model. If it gets 1 billion times weaker, then you have every right to reject the Christian faith as a viable scientific model. Now, some predictions I would make in closing. I would predict that the error bar in Christ as a designer will get progressively smaller and at a fairly rapid rate with advancing research. The divine design evidences will increase in both strength and number. And you're going to hear tomorrow that Guillermo Gonzalez and Jay Richards are going to tell you that these same characteristics also provide us with a place that gives us the best capacity to observe the universe. And it's also true that these characteristics give us the best physics to bring about a rapid conquest of the sin and evil. If you got questions, we have a daily telephone hotline. It operates every day except Christmas. Feel free to call us with questions on these issues. If you want to get the references, we can dig those out for you. I'd also recommend that you check out our webcast. 2 hours every week, we have a live show that we devote to the past week's scientific discoveries and their philosophical and theological significance. You're welcome to call in and ask questions or send emails. And if you're interested, we make available a free magazine. Somewhere here I got examples of it. Here it is. This is a magazine we make available free of charge if you want to be kept up to date with at least a few of these emerging scientific discoveries. So I got maybe, a few minutes for Q&A, and then we got to close it? Back to the hotline number.
About time for 2 questions, I would say we can do.
Thank you. Dr. Ross, what do you make of the so-called big attractor? Do you think that's the giant black hole?
Well, there's 2 things that astronomers talk about. They talk about the great attractor, and then lately they've been talking about the monster attractor. Okay, and to put this in context, I mentioned a little earlier that we live in this local group of galaxies on the extreme outer fringe of the Virgo supercluster. This is a huge cluster of galaxies, supercluster of galaxies, and the gravity of that supercluster is pulling us towards it. And so we're being pulled towards the center of the Virgo supercluster. But astronomers have determined that the Virgo supercluster is being pulled towards the great attractor. And so that's this very distant, even bigger conglomeration of clusters of galaxies. And then they've recently found that the great attractor is being pulled towards the monster attractor. Now then, we can actually determine the direction and the speed with which we're moving by two independent means. One is to look at the cosmic background radiation, the radiation left over from the creation event. And we see that it has a dipole structure. It's slightly hotter on one side than it is on the other side. It's one of the proofs that we live in a Big Bang universe. And what we notice is that that hot side of the cosmic background radiation is in the same direction of the velocities of distant galaxies we measure, which show us the direction to which we're being pulled. So the fact that those two line up, and it's about the value that we would expect for all decent cosmic models, shows us that we're on the right track. So yeah, we really are being pulled towards the great attractor, which is being pulled towards the monster attractor.
Thank you. Okay.
Hugh, since this cold dark matter and dark energy can neither be seen nor detected, how can they actually measure the quantity of these factors? They seem to be in the nature of free parameters rather than
Right.
something that you can't measure something you can't detect and you can't see.
Well, it is
You
true.
say that they've
Hold on.
actually measured these
Yes,
things.
they have measured it. We cannot see it because, by definition, exotic dark matter does not emit light or doesn't strongly interact with radiation. And dark energy, likewise, doesn't emit light. However, we can detect both because both have observable consequences. For example, the exotic
That's right.
dark matter.
You're measuring it by the consequences that you assumed if your evolutionary origin of the universe is true, according to the
No,
which
it's-
one you choose to. I don't know
it's
which one
simpler
you.
than that, Dwayne, in the sense that all bodies in the universe that have mass exert gravity. That's true of exotic dark matter. It's true of boronic matter as well. They both will exert a gravitational pull. And so one of the ways astronomers detect exotic dark matter is they measure the gravitational pull.
How do you measure that gravitational pull?
Well, there are many ways, but one of the easiest ways to get a handle on from a lay perspective is to look at gravitational lenses. And so, for example, if we see a distant cluster of galaxies that's acting as a gravitational lens, magnifying the light of a quasar that's behind it, that magnification will be in proportion to the total mass that makes up that cluster of galaxies. That total mass would include both the boronic matter and the exotic matter. Now, we can get a measure of the boronic matter from the light it emits, and so you have a measure of the total matter, you have a measure of the boronic matter, you subtract the two, and that gives you a measure of the exotic matter. Now, the most accurate way of getting a handle on this is through the cosmic background radiation maps. The W map was able to give us an accurate measure of the dark energy density, the exotic matter density, and the boronic matter density, 4.5% for the latter, 23% for the exotic dark matter, and 73% for the dark energy. And then you can go to things like the Sloan Digital Skies Survey of galaxies and again measure those three factors independently.
If this was true, then why weren't they aware of this dark energy, say 4 and 5 years ago, when they assumed the rate of expansion of the universe was decreasing? Then they got some data which seemed to indicate that it's increasing rather than decreasing, and so then they began to look for this so-called dark energy. Why, if you had other ways to doing this, why didn't they see that? Why didn't they detect it? Why don't we see it here right now where we are in existence?
Well,
I don't understand it.
Okay, I got the question. When I was a graduate student at the University of Toronto, the measuring tools we had at that time could not detect any non-linearity in the expansion of the universe. And so it was linear within our error bars over the whole span of cosmic time. What has happened in the last 30 years is that we've developed tools that allow us to see the non-linearity in the expansion of the universe, and it's that non-linearity. And by the way, it's not that great. It's about a 1% departure from linearity. So you do need sophisticated measuring tools to pull that off. And that's really why we didn't have accurate measures of these three factors until a year ago. I mean, that was the big discovery of 2003, is using these sophisticated tools to measure that nonlinearity to high accuracy.
Okay, thank you very much. It's now time